All right, folks, let me get your attention, please. If you could look up at the screen, you've got your packet in front of you. We're just going to chat about these. Hey, guys, come on. I'll give you a warning. Let's get moving here. I want to talk about these questions in A, B, and C because these are some kind of big questions, and they're not hugely mathematical. There's a little bit of philosophy going on here, honestly. This first one I thought is a really interesting question. Is it possible that a team could do this experiment and just keep flipping that last coin forever and ever and ever? Is it possible that it could happen? What do you guys think? Give me a thumbs up or a thumbs down. I'm really curious to see what we have to say. I'm not sure that I know the answer to this. I'm seeing lots of thumbs ups. Anybody want to elaborate on that? You did it forever and ever and ever? Forever and ever and ever? Theoretically, it could happen. Okay, what do you think? Right. So, and that's important with probability. Every time you do it, it's still a 50-50 chance. Even if you got 100 heads in a row, you would think like, well, it's got to come up tails eventually. But every time you do it, it's a 50-50 chance. I honestly don't know the answer to this. I think you would have to involve, could you guys please stop? Thanks. I think you would have to involve statistics and calculus together in order to answer this. And I don't know enough about how those two things work together. But it's a very interesting question. You would be very unlucky, I suppose, if it happened, or lucky, depending on your outlook. What about part B? I saw lots of different answers to this. If we had removed the heads instead of removing the tails, is that going to change the experiment significantly? What do you guys think? Thumbs up or thumbs down for that one? I saw both. I'm curious to see what we individually think. Is that going to change it significantly? I'm waiting on you guys over here. Thumbs up or thumbs down? If we had just kept the tails instead of keeping the heads, would that change it? Yeah, I'd say it depends on like your definition of significantly. Some of you had a lot more heads in general than you had tails, and so you were removing more than half each time. In general, though, I'd say it's kind of a 50-50 chance, so maybe not. I don't think there's a correct answer to that one either. Part C, if you started with 200 pennies instead of 100 pennies, what do you think would be different? What would you expect would be different? Say that again. They go on longer. How much longer? Would it go on twice as long? So like if a lot of you were getting out with it like around 7 or 8 trials, so do you think it would be more like 14 or 16 trials? Kind of, yeah, it depends. And that's the thing. This is like, it's not going to be the same every time. But let me ask you this. If you had 200 pennies in a cup and you dumped them out, about how many would you expect to keep after that first trial? Around 100. So I would say, I agree with you. I think we would just add one more trial. We wouldn't double the number of trials. We would just add one more because after that first trial, we're going to be pretty close to 100 after one trial. Agreed? Great. I'm hoping that you guys came up with, for part C down here, did you guys come up with a multiplier of 0.5? How many people predicted 0.5 when I asked you to do your prediction at the beginning? Anybody predict 0.5 way back then? Okay, a few people did, but it sounds like most of us came up with it here. I want you to tell me your equation, please. What did you all have for your starting value here in your equation? 100? And you just told me your multiplier was 0.5. Let's look at our data really quickly, guys. We're almost done. Stick with me. I appreciate you. Been a while since I've used this. All right, here's the data that you all input into the system. And you can see everybody's kind of starts off here at 100. Everybody's got a dot that overlaps here. And then it sort of spreads out from here, but generally it's curving down. So if I were to look at all your graphs right now, this would kind of show you what that would look like. But here's what I think is interesting. If we predict by our equation that most people would be around this equation we came up with, y equals 100 times 0.5 to the x power, notice how our data fits along that equation pretty well. Some of the dots are above it, some of the dots are below it, but we're pretty close to it. So this is a good example of Does that equation perfectly predict what everything is going to do every single time? No, but does it serve as a good like idea of like in general, how is this experiment going to go if we were to run it again? Awesome. All right, guys, you did awesome today. If you haven't already, please pick up the assignment, get started on it, collect up those pennies, and again, please look around on the floor and see if you see any pennies down there. Thank you again.